The Younger Dryas Impact. It didn't announce itself. No weeks of warning, no slow darkening of the horizon, no time to move the children to higher ground. The mammoths were grazing. The Clovis hunters were camped by the river. Then the sky over the ice sheet caught fire. And in geological terms, the kind of terms where 1,000 years is a rounding error, the world that existed that morning was gone by nightfall. We know this because of a line in the dirt, a thin, dark layer found in sediments across North America that geologists call the black mat. Below it, mammoth bones, mastodon teeth, the flint spear points of the Clovis people, the most sophisticated hunters North America had ever produced. Above it, nothing. Not a decline, not a transition, nothing. The black mat is not a gradual fade. It is a wall. In 2007, a team of 26 researchers led by Richard Firestone of Lawrence Berkeley National Laboratory published findings in the Proceedings of the National Academy of Sciences that tried to explain that wall. What they found inside the mat was not what anyone expected. Platinum group elements at concentrations up to 100 times background levels, the kind of concentrations that geologists associate with one thing, a cosmic impactor. Alongside the platinum, they found nanodiamonds, specifically a form called Lonsdale-Lead, a hexagonal diamond structure that does not form in nature under any process except a cosmic impact or a nuclear explosion. It was recovered from the black mat layer at sites across the continent. The charcoal record from this same horizon is staggering. Some analyses suggest that roughly 10% of the Earth's entire biomass burned simultaneously. Pollen records across North America show a near-total forest collapse at this boundary. Not a fire here, a drought there. Everything, everywhere, at once. Greenland ice cores dated to 10,890 years before the Common Era show a simultaneous spike in ammonium, nitrates, and charcoal. The atmospheric fingerprint of a continent burning. A 2018 study led by Christopher Moore of the University of South Carolina independently corroborated the platinum anomaly at White Pond in South Carolina, tightening the date to within a 100-year window. The impact signal was not a single-site anomaly. It was global. And then there are the Carolina Bays, roughly 500,000 shallow elliptical depressions scarring the eastern seaboard of the United States from New Jersey to Florida. They are still there. You can see them today from satellite imagery, from LiDAR scans, from an airplane window if you know what to look for. Every single one of them shares the same orientation, a consistent northwest to southeast alignment, as if they were all carved by the same force from the same direction at the same moment. Michael Davies and Thomas Harris published their LiDAR analysis in 2015, showing this alignment with uncomfortable precision. No conventional geological process produces 500,000 impact-oriented depressions simultaneously. No glacier, no wind, no water. The mainstream explanation for the megafauna collapse has long been a combination of climate warming and human overhunting. Paul Martin's overkill hypothesis. The glacial maximum was ending. Habitats were fragmenting. Human hunters, new to the continent and facing prey animals with no evolved fear response, could theoretically have driven slow-reproducing species like mammoths to local extinction within a few centuries. It's a rational model. It fits much of the evidence. But overhunting doesn't deposit platinum from the sky. It doesn't produce nanodiamonds. It doesn't explain why the Clovis people themselves, skilled, adaptable, continent-spanning, vanished from the archaeological record at the same horizon as the animals they were supposedly hunting. You don't disappear when your prey disappears. You find other prey. unless something else happened first. Some researchers ask whether the 500,000 scars on the eastern seaboard are the footprint of a fragmented comet, a swarm of debris that exploded over the Laurentide ice sheet and sent shock waves and ejecta across the continent in minutes. Others ask whether the flood myths that appear in cultures from the Americas to the Middle East, the stories of fire raining from heaven, of a world destroyed and remade, are not metaphors but memories. The oldest memories our species has, and perhaps the most accurate. We may never find a crater. The ice sheet that took the blow has been gone for 10,000 years. What we have instead are 500,000 holes in the ground, a line of platinum in the dirt, and a silence above the black mat where an entire world used to be. From the fire that may have ended one age, we descend into deep time, to a moment not 10,000 but 252 million years ago, when the Earth did not nearly end. It almost completely did. The Great Dying. Stand at the edge of the ocean and try to imagine it dying, not the creatures in it, the ocean itself, the chemistry, the oxygen gradients, the fundamental conditions that make complex life possible. That is what happened 252 million years ago. And it happened fast enough that the rocks don't record a transition. They record a wall. Geologists call it the end Permian extinction. Paleontologists call it the Great Dying. The numbers are almost too large to hold in your mind. 96% of all marine species, 70% of all terrestrial vertebrate species. Gone. Not reduced, not stressed, not gradually replaced. Gone. The most conservative estimates place the main extinction pulse at under 60,000 years. Some analyses of the sharpest stratigraphic sections suggest the marine kill could have occurred in under 20,000 years. In the context of a planet 4.5 billion years old, that is not slow. That is instantaneous. That is, by any biological measure, overnight. The clearest record sits in the Meishan section in Zhejiang Province, China, a limestone cliff face where the Permian-Triassic boundary is exposed in extraordinary resolution. In 2011, Xu Zhongshen and a team of researchers published a landmark study in Science, analyzing 333 marine sections globally. Using uranium lid dating of zircon crystals extracted from volcanic ash layers that bracket the extinction horizon, they pinned the boundary to 251,941,000 years ago, plus or minus 37,000 years. The main extinction pulse, under 60,000 years. For reference, 60,000 years is roughly the span between the earliest known cave art and today. The smoking gun is the Siberian Traps, a volcanic province covering approximately 7 million square kilometers, roughly the size of the continental United States, that erupted in a sustained, catastrophic outpouring of basaltic lava during this exact window. The volume of material released is estimated at somewhere between 2 and 4 million cubic kilometers. The CO2 and sulfur dioxide injected into the atmosphere would have simultaneously triggered ocean acidification, a short-term volcanic winter from sulfur aerosols, and then runaway greenhouse warming as the CO2 accumulated over millennia. The ocean temperature reconstructions are stunning. Oxygen isotope data from marine sediments suggest sea surface temperatures near the equator may have reached 40 degrees Celsius, above the thermal tolerance of essentially every marine organism alive at the time. What the carbon isotope record shows is perhaps the most disturbing detail. At the boundary, there is a sudden, dramatic negative excursion, a signature consistent with the near-total collapse of ocean photosynthesis. The surface ocean, in geological terms, stopped breathing. Microbial mats, simple bacterial films that dominate ecosystems when complex life has been stripped away, expanded across seafloors globally. On land, fungal spikes in the pollen record from multiple global sites indicate that the dominant organisms briefly became the ones that eat dead things. The forests were rotting, and nothing was growing back. The recovery took 10 million years. That is longer than the entirety of primate evolution. Not 10,000 years, not a million. 10 million years before the oceans returned to something resembling pre-extinction biodiversity. In that time, the world was effectively barren. A few lineages of hardy survivors, the Lystrosaurus, some early archosaurs, a handful of marine invertebrates, held on in a simplified, diminished, ghost ecology version of what had existed before. Geologists find the Siberian Trap's explanation largely satisfying. Volcanism on that scale produces the right gases in roughly the right sequence to drive the cascade of acidification, warming, and oxygen depletion that the fossil and geochemical record describes. It is a coherent model, it fits, but 60,000 years is still a long time to sustain a kill. Some sections show the main pulse occurring far faster than that, and the question of what exactly triggered the carbon isotope anomaly, the sudden productivity crash, remains genuinely contested. Was it the volcanism alone, or did a second mechanism trigger alongside it? A seafloor methane release, perhaps. A destabilization of deep water clathrates as temperatures rose. A kill mechanism inside a kill mechanism, each one accelerating the other until no feedback loop remained to stop it. What the rock-at-mation records is not a story of slow decline, it is a story of a threshold being crossed. And once crossed, the system did not find a new equilibrium. It collapsed. The question that follows most of us out of this is a quiet one. How close to that threshold does a biosphere have to be before crossing it stops being a geological possibility and starts being a geological schedule? From the deepest death in Earth history, we climb toward the surface of recorded time, to a collapse that was not geological but civilizational, to a world of palaces and trade routes and written language that ended so abruptly that someone was writing a letter when it happened. The unsent letter. The letter was never sent. That is the detail that stays with you. Somewhere in the archive of a burning palace on the Syrian coast, a clay tablet was pressed, inscribed in urgent cuneiform, and placed in the kiln to be fired and preserved for transit. The kiln was still hot when the city fell. The tablet sat there for 3,000 years, waiting for a messenger who was never coming. The city was Ugarit. The year was approximately 1185 before the Common Era. The letter was addressed to the king of Alatia, Cyprus, and it described ships attacking from the sea, the city's defenses stripped and deployed elsewhere, the situation desperate and deteriorating. We know all of this because French archaeologist Claude Schaeffer excavated the royal archive at Ras Shamra, the modern site of ancient Ugarit in the 20th century. The tablet was found still in the kiln, its message undelivered, Ugarit never recovered. It was destroyed so completely that it vanished from history entirely, its very existence unknown until archaeologists uncovered it less than 100 years ago. What makes Ugarit's fate extraordinary is not that a city was destroyed. Cities were destroyed all the time. What makes it extraordinary is the company it kept. George Washington University historian Eric Klein documented the full scope of the collapse in his 2014 book, and the picture he assembled is almost incomprehensible in its completeness. Within approximately 50 years, roughly 1100 and 200 to 1150 before the Common Era, every major palace civilization in the eastern Mediterranean ceased to exist. The Mycenaean Greeks. The Hittite Empire, which had been the dominant military power in the ancient Near East for centuries. The kingdoms of Alalakh, Hazar, Megiddo, and Egypt's new kingdom imperial reach which never recovered its former extent. An entire interconnected world, gone within a single human generation. The dendrochronological evidence, tree ring data from Anatolian timber, shows a sharp climate deterioration beginning around 1200 before the Common Era. Brandon Drake's 2012 study in the Journal of Archaeological Science analyzed marine sediment cores from the Gulf of Oman and found a dramatic spike in wind-blown dust at precisely this date, a reliable proxy for severe drought conditions affecting the entire eastern Mediterranean and Near East simultaneously. The drought is real. The climate signal is unambiguous. Egyptian records from the reign of Ramesses III describe the attackers in the Medinet Habu inscriptions with language that suggests civilizational catastrophe, whole nations uprooted and on the move. And yet Egypt itself barely survived, fighting off multiple naval and land invasions in a span of years and emerging diminished. The Linear B writing system, the earliest known form of written Greek used across the Mycenaean palace economy, disappears completely from the archaeological record. No Linear B tablet has been found above the destruction horizon. Literacy in Greece would not return for approximately 400 years. Isotope analysis of human remains from multiple collapse-era sites shows something quietly devastating: a shift in diet toward lower-quality foods in the decades before the final destruction layers. These populations were already hungry before the end came. The infrastructure was already failing. The system was already stressed. Eric Klein and most mainstream historians favor what they call a systems collapse model. A perfect storm of drought, internal rebellions, disrupted trade networks, earthquakes, and the pressure of displaced populations all arriving simultaneously in a civilization too interconnected and too fragile to absorb multiple shocks at once. It is a sophisticated and well-supported argument. The individual factors are all documented, but the synchronicity remains the problem. Drought weakens one region. Earthquakes damage one city. Even a major migratory movement travels at the speed of people walking. What ended a dozen distinct civilizations across hundreds of thousands of square kilometers within one human generation? The tablet from Ugarit was not written by a society in managed decline. It was written by someone who, right up until the moment the kiln fired, believed help was still possible, believed the world still worked, believed there was still time. Whether the final cause was climate or migration or something not yet identified in the record, the lesson of 1185 is the same one the Great Dying teaches, just compressed into human scale. The end does not always arrive slowly enough to be mistaken for something else. From a collapse that fell within living human memory, we travel back, much further back, to a moment not recorded in any text, not remembered by any culture, but written into the genetic code of every person alive today. The near death of humanity. Every human being alive today, all 8 billion of us, may be descended from a single remnant population that huddled through a 6-year winter and survived by the narrowest possible margin. The volcano that created that winter is still there. It sits in Sumatra, Indonesia, and it is 100 kilometers long. You can sail a boat across it. It is today a beautiful lake. 74,000 years ago, it was the largest volcanic eruption in the last 2 million years. The Mount Toba supervolcano produced what geologists classify as a VEI-8 eruption, the maximum known category, ejecting approximately 2,800 cubic kilometers of volcanic material into the atmosphere. To put that number in context, the 1981 eruption of Mount St. Helens ejected roughly 1 cubic kilometer. Toba ejected 2,800 times that. The resulting ash layer, the youngest Toba tuff, is identifiable in sediment cores across the Indian Ocean, South Asia, and East Africa. In parts of India, it is 35 centimeters thick, the largest individual volcanic ash deposit in the known geological record. Sulfate spikes from the Toba eruption have been independently identified in ice cores from both Greenland and Antarctica, confirming that the eruption's atmospheric effects were genuinely global. The sulfuric acid aerosols injected into the stratosphere are estimated to have reduced global temperatures by 3 to 5 degrees Celsius and maintained that reduction for up to 6 years. 6 years of reduced sunlight, 6 years of failed harvests, 6 years in which every food chain dependent on photosynthesis was compromised. Paleoanthropologist Stanley Ambrose of the University of Illinois connected this eruption to something stranger and more personal in a landmark 1998 paper in the Journal of Human Evolution. He pointed to the genetic record. Modern humans are, by every measure of molecular diversity, an extraordinarily homogeneous species for our size and global distribution. A single social group of chimpanzees in a forest in Africa can carry more mitochondrial genetic diversity than all 8 billion living human beings combined. That is not normal. That is the genetic signature of a catastrophic population reduction, a bottleneck, somewhere in our recent ancestral past. The timing fits. Pollen cores from Lake Malawi in Africa show a dramatic vegetation collapse and recovery window consistent with a 6 to 10 year volcanic winter immediately following 74,000 years before the present. Archaeologist Curtis Marian of Arizona State University documented evidence of human occupation continuing through the Toba ash layer at Pinnacle Point in South Africa in a 2010 study. One of the few sites that suggests a small coastal population sustained by shellfish and marine resources may have been the primary human survival refuge during the worst of the volcanic winter. And in India, a study by Petraglia and colleagues published in Science in 2007 found a cultural discontinuity directly in the Toba ash layer. The tools below the ash are different from the tools above it. The people on either side of the eruption were not the same people. Some geneticists dispute the bottleneck hypothesis entirely, arguing that human genetic homogeneity reflects our African origins rather than a specific catastrophic event. The volcanic winter, they contend, may not have been geographically uniform enough to reduce a continental African population to a few thousand individuals. It is a legitimate critique. The genetic evidence for a bottleneck is real. The assignment of its cause to Toba specifically remains debated. But the homogeneity is there regardless of what caused it. We are a species that almost wasn't. Something, Toba, or something we have not yet identified, compressed the entire human lineage through a needle's eye. And the people who emerged on the other side, possibly no more numerous than the population of a small village today, were carrying everything. Every language that would ever be spoken. Every myth, every memory, every capacity for art and music and science, compressed into a few thousand survivors on a warming coastline, waiting for the sky to clear. If those survivors had not made it, if the shellfish ran out, if one more year of ash-dimmed summer pushed them past a threshold they couldn't cross, this conversation would not be happening. None of the conversations that have ever happened would have happened. It is, arguably, the most important near miss in the history of complex life on this planet. From one catastrophe that nearly erased a species, we move to one that erased 3 civilizations simultaneously. And did it not with fire or volcanic winter, but with the oldest and simplest weapon the planet has, thirst, the silent century. The granary was full when they left. That is the detail that archaeologists keep returning to. The people of Tel Leilan in northeastern Syria did not leave because they had been invaded or defeated or burned out. They left their grain storage intact, their city gates open, their streets not looted, not destroyed, just empty. And then the desert moved in. Within a generation, the wind had buried the streets under a thick layer of clean, artifact-free sediment. They did not come back for 300 years. Yale archaeologist Harvey Weiss led the excavation of Tel Leilan in the 1980s and identified the abandonment layer in 1993. He measured it. 30 centimeters of wind-blown sediment containing no cultural material, no animal bones, no organic refuse of any kind. The kind of layer that forms when a site is not just empty of people, but empty of everything that lives. He published his findings in Science in 1993 with a claim that many of his colleagues initially resisted, that an abrupt climate event, not human agency, had caused the simultaneous collapse of the Akkadian Empire, the world's first true empire, which had governed Mesopotamia for over a century. The climate signal, it turned out, was real, and it was not local. Speleotham records, the chemical record preserved in cave stalagmites, from Quinniff Cave in Oman show a dramatic reduction in monsoon rainfall at approximately 4,200 years before the present, with the signal visible in oxygen isotope ratios and lasting approximately 200 years. Pollen cores from multiple eastern Mediterranean sites show the same aridification signal. The Saprapel record from the seafloor of the eastern Mediterranean, layers of organic sediment formed during periods of higher river runoff, shows a gap at this date consistent with drastically reduced Nile and river discharge. East Africa's climate signal appears in the Kilimanjaro ice core as a distinct dust layer. This is the 4.2 kiloyear event, and it did not stop at Mesopotamia. In Egypt, the Old Kingdom, the civilization that built the Great Pyramids, collapsed into what Egyptologists call the First Intermediate Period, a fragmented, decentralized era described in contemporary texts with language of famine, severe enough to include references to acts that polite historiography tends to summarize vaguely. The Nile flood records from this period show consistently reduced inundation, consistent with East African drought. In the Indus Valley, Harappa, and Mohenjo-Daro, cities with sophisticated sewage systems, standardized weights and measures, and a script we still cannot read, show declining craft specialization and contracting populations beginning around this date, before the cities were eventually abandoned entirely. A systematic review by Clare and Wenninger in 2010 documented over 100 Neolithic and Bronze Age site abandonments across the Near East in a 100 to 200 year window centered on 4,200 years before the present. 4 of the world's most advanced civilizations, 4 separate continents, different agricultural systems, different climatic dependencies, all showing stress signals within the same narrow window. Climatologists attribute the 4.2 kiloyear event to a disruption in the global thermohaline circulation, the ocean conveyor belt that distributes heat from the tropics toward the poles, possibly triggered by the final melting of remnant Laurentide ice. This would have altered monsoon systems globally, reducing rainfall across a broad band from China through South Asia, the Middle East, and North Africa. It is a well-grounded model. The physics are sound, but the synchronicity still nags. Drought should not knock down civilizations with different water sources in different ecological zones at the same time. Egypt had the Nile. Mesopotamia had 2 rivers and a sophisticated irrigation network. The Indus Valley had monsoon recharge. They should have failed at different times for different reasons by different mechanisms. Instead, they faltered together within what in human terms is a single lifetime. And there is one more detail from Tel Leilan that Weiss documented and that tends to stay with people who read his original report. In the years immediately before the abandonment, the Akkadian governor of the city constructed a massive new wall, 90 meters wide at the base, across the northern frontier of the empire. Not a military fortification. An enclosure designed, Weiss argues, to control the movement of people being driven southward by drought from the surrounding steppe lands. The empire did not collapse from outside. It was swamped from within by its own climate refugees. The last thing the governor built, before the granary was sealed and the gates left open and the wind came in, was a wall to keep out the people the drought had made desperate. 3 civilizations fell to thirst. The next event on this list did not kill a civilization. It killed a world. And it announced itself not with drought or fire or cosmic impact, but with silence. The silence of a forest that simply stopped existing. The silent forests. In the rock beneath Connecticut, there is a line, not a metaphorical line, a physical one, a boundary in the stone that any geologist can point to and date. Below it, footprints, the tracks of Crurotarsan archosaurs, massive crocodile-like creatures that dominated the Triassic world, Rauisuchians, Etosaurs, the first proto-mammals, 201 million years of evolution walking across ancient mud preserved in stone, and above the line, nothing. A paper-thin gap, and then new footprints, smaller, bipedal. The first unambiguous tracks of the dinosaur age. The world did not transition between those 2 layers. It was replaced. This is the end Triassic extinction, and it is one of the least discussed of the 5 major mass extinctions in Earth history, which is strange because its kill mechanism is one of the most disturbing. 76% of all species vanished. But the detail that makes this extinction uniquely unsettling is not in the bones. It is in the pollen. In stratigraphic sections from Greenland, Europe, and North America, there is a feature called the fern spike. It is a layer in which normal forest pollen, conifers, cycads, the complex assemblage of a functioning Triassic ecosystem, disappears almost instantaneously in the sediment record and is replaced entirely by fern spores. Ferns are colonizers. They move in after catastrophe into scorched and devastated landscapes where more complex plants cannot yet establish themselves. The fern spike means the forests of the northern hemisphere effectively cease to exist at the boundary. And in some sections, the transition from complex forest pollen to pure fern spore occurs within a layer just a few centimeters thick. At normal sedimentation rates, that represents at most a few thousand years, possibly far less. In 2013, a team led by Terence Blackburn of the Carnegie Institution for Science published a study in Science using high-precision uranium-lead dating of zircon crystals from basalt flows of the Central Atlantic Magmatic Province, CAMP, interbedded with the fossil record. Their result was striking. The extinction pulse and the onset of camp volcanism were simultaneous to within the resolution of the dating method. Effectively, the same moment in geological time. Camp was extraordinary in scale. It covered approximately 11 million square kilometers across what are now North America, Europe, Africa, and South America, the continents that were rifting apart to form the early Atlantic. Total lava volume estimates run into the millions of cubic kilometers. The CO2 and sulfur dioxide released would have been sufficient to simultaneously drive ocean acidification, a short-term volcanic winter, and then sustained greenhouse warming. Carbon dioxide modeling based on stomatal density measurements from fossil leaves at the boundary shows atmospheric CO2 doubling or tripling within a geologically brief period. Paul Olson of Columbia University's Lamont Doherty Earth Observatory has spent decades documenting the footprint assemblages of the Hartford Basin in Connecticut and New Jersey. one of the clearest terrestrial records of the boundary. What he describes is not a gradual faunal turnover. It is a hard cut. Crurotarsan tracks are present, abundant, diverse, and then they are absent. Dinosaurian tracks appear above the boundary. There is no transitional community. No mixed fauna, suggesting a slow, competitive replacement. The line in the stone is not a gradient. It is a threshold. Marine records from the ancient Tethys Ocean show a simultaneous carbonate crisis. The global collapse of reef-building organisms, their shells dissolving in acidified water, their ecosystems dismantled within the same narrow horizon. And the recovery of forest ecosystems after the end Triassic took between 1 and 4 million years in different regions, one of the longest ecological recovery periods of any Mesozoic event. The mainstream explanation, camp volcanism driving a cascade of acidification, warming, and ecosystem collapse, is well supported and broadly accepted. Volcanism of that scale produces exactly the right sequence of environmental insults to explain what the record shows. But the fern spike is not volcanic timescales. In the sections where it is sharpest, it is centimeters. Forests do not vanish globally, simultaneously, in centimeters of sediment, not from slow volcanism. Something about the mechanism was faster than the models suggest. A methane clathrate destabilization, perhaps triggered by the initial warming. A second kill mechanism layered on top of the first, compressing what should have been a 100,000-year transition into something measurable in geological eye blinks. The footprints below the line had no way of knowing the line was coming. That is the thing about thresholds. You do not feel them approaching. You simply cross them. Every extinction we have visited so far has left physical evidence. A platinum layer, a pile of ash, an abandoned granary, a fern spike in the rock. But the next event on this list killed 85% of all marine life, and the leading hypothesis for how it did so left almost no physical evidence at all. Because the kill came from a direction geologists do not normally look. It came from space. And it traveled at the speed of light, death from the sky. There was no warning. That is the first thing to understand. No incoming asteroid visible in the sky for weeks. No volcanic rumbling. No drought slowly drying the rivers. No ships of invaders on the horizon. The trilobites and brachiopods and graptolites were simply there, in their hundreds of thousands of species, filling the shallow tropical seas of the Ordovician world. And then, in the fossil record, they were not. And the leading hypothesis for what killed them had left its source star perhaps 6,000 light-years away, crossed the void of space, and arrived here at the speed of light. Nothing on Earth would have seen it coming. Nothing on Earth could have. This is the end Ordovician extinction, 443 million years ago. It was the second largest mass extinction in Earth's history. Approximately 85% of all marine species were eliminated in 2 rapid pulses. And unlike every other major mass extinction, it lacks a clear geological cause at the boundary. No impact crater, no massive volcanic province erupting in the critical window. No obvious ocean chemistry crash that precedes the first pulse. The kill mechanism is, in the most technically precise sense of the word, unknown. In 2004, astrophysicists Brian Thomas of Washburn University and Adrian Mullott of the University of Kansas published a hypothesis in the International Journal of Astrobiology that attempted to explain what nothing else could. A long-duration gamma ray burst from a nearby star, nearby in galactic terms, within 6,000 light-years, would deliver sufficient radiation to destroy approximately 50% of the ozone layer over the hemisphere, facing the burst within 10 seconds. Not 10 years, not 10,000 years, 10 seconds. The effects on the ozone layer would persist for years, exposing surface life on the illuminated hemisphere to lethal ultraviolet radiation. The high-energy radiation would also trigger photochemical reactions in the stratosphere, converting nitrogen gases into nitric oxide and nitrogen dioxide, compounds that would destroy additional ozone and eventually fall as acid rain. The key piece of evidence that drove Thomas and Mellott toward this hypothesis was the pattern of the first extinction pulse. It was not random. Organisms in shallow tropical marine environments died first and hardest. Organisms in deeper water and organisms at higher latitudes were relatively spared. That geographic selectivity, equatorial vulnerability, polar refuge, is not the pattern produced by glaciation or volcanism. Glaciation kills organisms based on temperature tolerance. Volcanism disperses its effects through ocean chemistry and atmospheric chemistry, which do not respect latitude in the same way. Differential UV radiation exposure based on proximity to the equator produces exactly this pattern. Thomas and Mellott argued in their 2004 paper that the first extinction pulse fits the footprint of radiation damage better than any other proposed mechanism. The subsequent Ordovician glaciation, sheets of ice forming over what is now the Sahara Desert at a time when atmospheric CO2 levels were far too high for normal glaciation to initiate, may itself be a consequence of the gamma-ray burst. Photochemical destruction of stratospheric gases can trigger rapid cooling through changes in greenhouse gas chemistry. The burst in this model would have simultaneously irradiated the sunlit hemisphere and set in motion the climate mechanism that produced the second extinction pulse. Most geologists attribute the end Ordovician to a combination of Gondwanan glaciation, possibly driven by the drawdown of CO2 by the spread of early land plants, and the sea level fall that accompanied the expansion of polar ice sheets. It is a standard, well-supported climate-driven model. The glaciation is unambiguous in the rock record, but the timing of the first pulse is still faster than climate models comfortably explain. And the selectivity. Equatorial species hardest hit, deeper and higher latitude organisms spared, is still the wrong shape for a climate event. Climate does not kill by latitude. Radiation does. What makes the gamma-ray burst hypothesis genuinely unsettling is not that it cannot be tested. It is that, if correct, it cannot be detected. A gamma-ray burst leaves no crater, no ash layer, no iridium anomaly, no chemical signature in the rock that we currently know how to identify. It passes through the atmosphere, does its damage, and leaves nothing behind but the bodies. And somewhere in the constellation Sagittarius, a binary star system called WR104, approximately 8,000 light-years away, is currently considered by astrophysicists to be a candidate for producing exactly this kind of burst, with its rotational axis potentially oriented in Earth's direction. We may never know what killed the Ordovician. The extinction boundary has no smoking gun because the gun fired from 6,000 light-years away and left nothing in the rock but the silence above the kill horizon. From invisible death arriving at the speed of light, we descend to the deepest mystery of all, an entire kingdom of life so completely erased that it left no descendants, no echoes, nothing. Just a hard boundary in the fossil record, below which something lived and above which something utterly different replaced it. The kingdom that never came back. They were not animals exactly, they were not plants. Calling them either would be importing categories they did not fit into. They were something else. A different solution to the problem of being a large, complex organism. Soft-bodied. Fractal in structure. Some of them resembling sea pens, others like quilted mattresses, others like nothing alive today or in any other fossil record. They covered the seafloors of the world for 40 million years. And then, at the boundary we call the beginning of the Cambrian, they were gone, not reduced, not transformed into something smaller. Gone. And the world that replaced them was so completely different that paleontologists spent decades debating whether the Ediacarans were even animals at all. Because the things that replaced them bore no relationship to anything that had existed before. The Ediacaran biota were first described seriously by Australian geologist Reginald Sprigg after he found fossils in the Ediacara Hills of South Australia in 1946, though they were initially dismissed as non-biological. The systematic study of their extinction was advanced substantially by Simon Conway Morris of Cambridge University through his work connecting, or failing to connect, Ediacaran body plans to the Cambrian explosion that followed them. The Mistaken Point Ecological Reserve in Newfoundland, Canada, designated a UNESCO World Heritage Site in 2016, preserves what are among the last surviving Ediacaran communities, smothered by a volcanic ashfall and preserved in extraordinary detail on wave-scoured cliff faces at the edge of the Atlantic. The core impossibility is this: not a single identified Ediacaran body plan has a confirmed descendant in the Cambrian fauna. Not one. The Cambrian explosion produced in under 25 million years representatives of virtually every animal phylum alive today. Eyes, shells, legs, guts, complex nervous systems, predation, the entire ecological architecture of the modern ocean. None of it descended clearly from the organisms that had dominated the seafloor for the preceding 40 million years. The transition is not a replacement. It is an erasure followed by an entirely new vocabulary of life. A 2019 study by Darroch and colleagues in Nature Ecology and Evolution documented evidence of direct competitive replacement at some sites, as small, burrowing Cambrian-style organisms appear in the sediment record. Ediacaran diversity drops. The arrival of bioturbation, organisms burrowing through seafloor sediments for the first time, destroyed the oxygen-depleted microbially stabilized sediment surface that Ediacaran organisms depended on for both attachment and nutrition. In ecological terms, the burrowers dug up the floor of the Ediacaran's world and did not stop until the world was gone. The carbon isotope record at the Ediacaran-Cambrian boundary shows one of the largest and most rapid negative excursions in the Precambrian record, a massive perturbation to the global carbon cycle occurring precisely at this transition. Ediacaran fossils are found on every continent in a range of marine environments across 40 million years of geological time. They were neither geographically restricted nor ecologically marginal. Their complete elimination requires a global mechanism of some kind, not merely a local competitive pressure. And then there is the argument made by Adolf Seilacher of the University of Tübingen that the Ediacarans were not the ancestors of the Cambrian animals at all, but a fundamentally separate experiment in complex life, what he called the Vendobionta, representing a grade of biological organization with no living descendants and no evolutionary connection to anything that exists today. If Seilacher was right, their extinction was not the pruning of a branch on the tree of life. It was the destruction of an entirely parallel tree. The mainstream view increasingly points to ecological displacement as the primary driver. New Cambrian organisms with predation, mobility, and burrowing capability outcompeting passive sessile Ediacarans across the global seafloor. It is a reasonable and well-evidenced argument. Competition is a powerful force. But competition does not explain why not a single Ediacaran body plan survived in any refuge. Not in deep water, not at high latitudes, not in oxygen minimum zones where Cambrian predators could not follow. Competitive exclusion leaves survivors in marginal habitats. What happened to the Ediacarans left nothing, and that totality is strange. It suggests something more than competition, something that closed every door at once. The question that stays with you is a simple one. Complex life appeared once, built an entire world, ran it for 40 million years, and was completely erased. If that happened once, is there any reason to believe it happened only once? From the deepest mystery in the fossil record, we climb forward to an event that unfolded not over millions of years, but over a single human lifetime. A climate catastrophe so precisely timed that it fell within living memory, and whose physical record can be read today in the silence of abandoned mud brick rooms. The 8-foot cold. It was the closest thing to a city that the world then had. Thousands of people living in mud brick houses packed so tightly together that there were no streets between them. You entered through a hole in the roof and descended by ladder into your home. They had painted plaster walls. They kept cattle skulls mounted above their doorways. They practiced rituals that archaeologists are still trying to decode. And they had been doing all of this continuously at Çatalhöyük in central Anatolia for over 1,000 years. And then, in the mud brick archive of the site, there is a gap. Not a destruction layer, not a fire horizon, not the scorch marks of an enemy. Just silence and wind-blown sediment where the city used to be. The event that produced that gap is called the 8.2 kiloyear event. It was first clearly identified in the Greenland GISP2 ice core by Alley and colleagues in a 1997 paper in the journal Geology. A sharp temperature depression of approximately 1.5 to 3 degrees Celsius appearing at 8,200 years before the present, representing the coldest post-glacial period in the entire Holocene record. The cause was identified as something that had been building for centuries. The catastrophic drainage of two glacial lakes, Lake Agassiz and Lake Ojibwe, in what is now northern Canada. These were not ordinary lakes. Together they held more fresh water than all the Great Lakes combined. When the ice dam holding them back finally failed, approximately 163,000 cubic kilometers of fresh water discharged into the Hudson Strait and North Atlantic over a period estimated at as little as a few years. That freshwater pulse diluted the salty surface water of the North Atlantic, reduced its density, and dramatically weakened the thermohaline circulation, the ocean conveyor belt that pumps warm tropical water northward and keeps the northern hemisphere significantly warmer than its latitude would otherwise allow. The conveyor slowed. The northern hemisphere cooled. The cooling affected monsoon systems from East Africa to South Asia to the Middle East, and it maintained that cooling for approximately 160 years. At Çatalhöyük, excavated by Ian Hodder of Stanford University, the stratigraphic record shows a dramatic reduction in population and evidence of partial site abandonment in the occupation levels dated to approximately 6,200 before the Common Era. The people did not die there. They left, but they did not come back in any recognizable cultural continuity for generations. A systematic review by Clare and Wenninger in 2010 documented over 100 Neolithic site abandonments across the Near East in a 100 to 200 year window centered precisely on this date. Ain Ghazal in modern Jordan, a settlement with an estimated population of 2,000 to 3,000 people, shows abandonment of its outer residential areas at approximately this same date. The pattern is not random. It is a single signal, appearing simultaneously across an entire cultural zone. Pollen records from the British Isles, Scandinavia, and Northern Europe show a rapid vegetation shift at the 8.2 kiloyear horizon. Arboreal species retreating, cold-tolerant herbs expanding, consistent with a 1 to 2 degree regional cooling. Estimates suggest an associated sea level rise of between approximately half a meter and over a meter as the freshwater pulse rearranged global ocean volumes, simultaneously flooding coastal Neolithic settlements around the Black Sea, the Persian Gulf, and the eastern Mediterranean. Climatologists regard the 8.2 kiloyear event as a real but bounded perturbation, a brief cold episode within an otherwise warm Holocene interglacial. Most abandoned sites show reoccupation within a few generations, suggesting dispersal and return rather than permanent elimination. The event was a stressor, not an extinction, and may actually have spread farming communities across Europe as displaced Near Eastern populations carried agricultural knowledge into new territories. But 160 years is not brief when you are living it. 160 years in a pre-literate society, among subsistence farmers with no food reserves and no climate science and no understanding of what had changed, is generational. The grandchildren of the people who abandoned Çatalhöyük had no direct memory of what had existed before. The oral traditions, the agricultural knowledge specific to that land, the ritual practices of that specific community, these did not survive in any form we can recover. A gap in the mud brick record is also a gap in the record of everything those people knew. And then there is the question that some researchers have asked quietly without committing to an answer. Could the freshwater flood of 163,000 cubic kilometers entering the North Atlantic over a few years be the geographical kernel of the flood myths that preserved themselves in cultures from Mesopotamia to South Asia for the next 6,000 years? Not an allegory, a memory, the oldest memory of a world that changed so fast that the people living through it could not explain it as anything other than an act of God. From a cold snap that reset Neolithic civilization in a human lifetime, we arrive at the most documented, most studied, most certain mass extinction in the scientific record. And even this one, the one with the crater, the iridium, the global kill layer, is still not fully explained. The 6-minute winter. Geologists who work the Hell Creek Formation in eastern Montana call it the boundary. Not a boundary, the boundary. You can hold it between two fingers, a centimeter of clay, rust-colored and dense with iridium, sitting between a world that had dinosaurs and a world that did not. Below it, hadrosaur bones, ceratopsian teeth, the intact fauna of a late Cretaceous floodplain. Above it, nothing that any paleontologist would recognize. You could step over it in a single stride. The creatures below it never had that option. In 1980, physicist Luis Alvarez and his geologist son Walter Alvarez published a paper in Science that would permanently change how we understand catastrophe. The iridium anomaly at the Cretaceous-Paleogene boundary. The elevated concentration of a platinum group element associated with cosmic impactors was present not just at their Italian study site at Gubbio, but in every continuous geological section on Earth. Marine and terrestrial, Arctic and tropical. The same thin layer, the same chemical signature, the same stratigraphic position. Global, simultaneous. The Chicxulub crater, 180 kilometers wide, buried beneath the Yucatan Peninsula and the Gulf of Mexico, was confirmed in 1991 by Alan Hildebrand and colleagues. Argon dating by Paul Wren's team, published in Science in 2013, placed the impact at 66,038,000 years ago, plus or minus 25,000 years. The impactor was somewhere between 10 and 15 kilometers across. It was traveling at approximately 20 kilometers per second when it hit the shallow carbonate shelf of the Yucatan. The energy released is calculated at roughly 100 teratons of TNT, approximately 6 billion times the energy of the Hiroshima bomb delivered in a single instant. The fireball was visible from halfway around the planet. Ejecta re-entering the atmosphere created a brief thermal pulse, what some researchers call a global broiler event, in which surface temperatures spiked lethally across large portions of the hemisphere. That lasted minutes to hours. Then the longer killing began. Sulfur isotope analysis, published by Joanna Morgan and colleagues in 2016, indicates that the impactor struck sulfate-rich evaporate rock formations, injecting an estimated 325 billion tons of sulfur into the stratosphere. That sulfur, combined with impact dust, reduced solar radiation to near-zero levels for months, possibly years. The impact winter was not a metaphor. Photosynthesis in the surface ocean collapsed. High-resolution carbon isotope work at multiple boundary sections shows marine productivity crashing effectively instantaneously at the KPG horizon. In 2019, Robert De Palma of the University of Manchester published analysis of a remarkable site in North Dakota called Tanis. The site records, in a single depositional layer, a tangled assemblage of freshwater and marine fish, plant material, and glass spherules, solidified ejecta droplets, found lodged in the gill arches of the fish. The spherules had been raining from the sky while the fish were still breathing. The fish had died from a Seiche wave triggered by the impact's seismic energy arriving within hours of the strike. The site is not a metaphor for the impact's speed. It is a photograph of the impact day, preserved in mud. The survival profile of the KPG boundary is, in some ways, the strangest thing about it. Non-avian dinosaurs were eliminated globally. Every land animal above roughly 25 kilograms was effectively removed from terrestrial ecosystems, and yet crocodilians survived, turtles survived, small birds survived, small mammals survived. The pattern is consistent with a period of prolonged darkness and cold in which animals that could hibernate underground and did not depend on terrestrial food chains had the best chance. The selective pressure was not size alone. It was metabolic flexibility and ecological independence. Animals that could wait out the dark on stored energy or aquatic food resources lived. Animals that required a functioning terrestrial ecosystem to survive within weeks did not. Joanna Morgan's sulfur work also revealed something else. The Deccan Traps volcanism in India, a separate massive volcanic event already erupting before the impact, accelerated dramatically within 50,000 years of the Chicxulub strike. Shoney and colleagues published this finding in 2019, suggesting that the seismic energy of the impact itself destabilized the mantle plume driving the Deccan eruptions. A kill mechanism accelerating a second kill mechanism. The asteroid hit, and the planet responded by also erupting. And yet the crocodile lived. That is the detail that does not resolve. Crocodilians are not small. They are not burrowers. They are cold-blooded ectotherms that require warm environmental temperatures to function, exactly the conditions that the impact winter destroyed. By the survival model, they should have died with the dinosaurs. Instead, they are alive today, functionally unchanged, watching from the riverbanks of every tropical continent. No one has a fully satisfying explanation for why. It is as if the rules of the extinction applied to everything except the things that shouldn't have survived it, and that anomaly sits in the fossil record like a question no amount of iridium can fully answer. 10 extinctions. 10 moments when the world as it existed simply stopped. A comet's fire over an ice sheet. An ocean that forgot how to hold oxygen. A drought that outlived 3 empires. A kingdom of life so completely deleted, it left no descendants, no echoes, nothing. a kill that may have crossed 6,000 light-years without leaving a single piece of physical evidence. These are not isolated accidents. They are a pattern. And the pattern says the same thing every time. The Earth does not end slowly, it ends in sentences, complete ones, with periods. The official framework is sound on the individual mechanisms: volcanism, impacts, climate shifts, ocean chemistry disruption. These are real, measured, documented. Science has done extraordinary work reconstructing events from 250 million-year-old rocks and microgram quantities of platinum. The individual explanations hold up under scrutiny, but the official framework has a consistent blind spot. It almost always underestimates the speed. Every time a new high-resolution study comes in, the extinction boundary gets sharper, the transitions get faster, the kill gets more sudden. The mainstream keeps reaching for slower explanations for faster and faster evidence. What this list is, underneath all the iridium layers and fern spikes and abandoned granaries, is a record of thresholds. The Earth has thresholds. Cross them by a degree of warming, a sulfur spike, a freshwater flood, a pulse of radiation from 6,000 light-years away. And the system does not gradually adjust. It tips. And on the other side of the tip, the world that existed before is gone as completely as the Ediacarans, as irreversibly as the last Clovis hunter watching the sky catch fire. The mainstream view says each of these events had a specific identifiable trigger, and that understanding those triggers is the work of science. That is true. But the alternative view, the one that lives in the gap between the trigger and the speed of the response, asks whether we have correctly estimated how close to the next threshold we currently are, and whether the answer to that question would change anything if we knew it. Most people encounter these events as paragraphs in a textbook and move on. You made it here. You read the centimeter of clay and the 30 centimeters of wind-blown sediment and the 10 seconds it would take a gamma-ray burst to strip the ozone from a hemisphere. You notice that the boundary is always thin. That noticing is not comfortable, but it is honest. This channel exists for the people who take the thin layer seriously, who understand that history, all of it geological and civilizational, is a record of how fast things can end and how rarely anything on the other side of the ending remembers what came before. If that's why you're here, hit subscribe. And then go to the comments and answer this. Of all 10 events on this list, which one do you think we are closest to repeating? And what would it take for anyone in power to actually believe you? The boundary is always thin. That is the one truth every extinction on this list shares. Not the cause, not the scale, not the few species that somehow made it through, but the thinness of the line between everything and nothing. 1 centimeter of iridium-laced clay, 1 layer of fern spores where a forest used to be, 1 granary full of grain with the gate left open and nobody coming back, 1 clay tablet, urgent and complete, still in the kiln. The world does not warn you when it ends, it draws a line in the rock. And everything below that line is a world that used to exist. Subscribe because the line is thinner than it looks.